Hi everyone, this is the second video of a basic sound and music theory series. If you haven't watched the first one, called Basic Sound Theory, I suggest you watch it first. I'll leave a link in the description. Okay, so the focus in this video is on basic music theory, so let's start. Pitch, volume, timbre, and overtones are all natural properties of sound that exist with or without human intervention. However, humans around the world have created instruments, harmony, and different music systems. In Western European cultures, the overtone properties of sound has a very important role in the development of music, harmony, and the tonal music system. In the tonal system, two of the most common ways to name the sounds that have a specific pitch are using the letters A, B, C, D, E, F, and G, or the syllables La, Si, Do, Re, Mi, Fa, Sol. The way that the notes are tuned in this system has been standardized so that the note A that is close to the midpoint of the audible range is tuned to 440 Hz. Therefore, the lowest audible A is tuned at 27.5 Hz. The next A is tuned at 55 Hz, then 110, 220 Hz, and so on, doubling the frequency with each increment. Then, the tuning of all the other notes is relative to A440. Tuning in the tonal system aligns with the overtone property, where the first overtone of every sound has the closest relationship with the note that originated it. And if a musical instrument produces a note that has the pitch of that overtone, both notes will have the same name. Therefore, if the original note is called A, then the note that is tuned to its first overtone is going to be called A as well. In this system, the distance or interval between those two notes or any pair of notes related to each other by the first overtone is an octave. The following sounds that you will hear are an octave apart. And if they are played simultaneously, they sound in tune because the frequency of one is the exact double of the other. If a melody is played twice, each time an octave apart from the other, the second iteration is perceived by the human ear as the same melody. Therefore, if we listen to a song, and later we listen to the same song performed an octave higher by a different singer with a higher pitched voice, we can recognize it as the same song because both versions have the same melody pattern, and the second one is an octave higher. Moving on, if a note is tuned to the pitch of the second overtone, it will be 1/5 above the octave of the fundamental note, and it's going to be the first note tuned to an overtone that does not share the name with the fundamental. The interval produced by the first and second overtones of any note is a perfect fifth, and this interval is essential to the structure of the tonal system. If we make a chain of notes using a perfect fifth between them, every note in the system eventually will be part of it. Let's start this chain with the note F. A perfect fifth above F, we have C. A perfect fifth above C, we have G. Then D, A, E, and B. Consequently, all the notes in the chain are produced using the second interval of the overtone series. One way to visualize this note sequence is by arranging the chain in a spiral of fifths. At this point, of the tonal system's reconstruction exercise, we have 7 notes. And if we rearrange them by pitch proximity rather than fifths, starting with C, going up in pitch, the closest note at 1 tone distance is D. Next, also 1 tone up is E, then half a tone up is F, then 1 tone up is G, another tone up is A, 1 more tone up is B, and half a tone up more, we're back at C. But this second appearance of C is an octave above the starting note. Now we can put together a chart using this structure. The chart shows the structure of the major scale identified by the major third interval from the tonic. If a music piece is composed using the tonal system, the tonality has to be established by presenting 2 or more notes from the scale followed by the tonic. Let's listen to some examples of note sequences that establish the tonality. Then the degrees and intervals acquire functions that become expected by the listener. The tonic becomes the most stable sound, where the music melodies and phrases rest. Also, the leading tone becomes the most unstable degree, which craves to be resolved to the tonic for conclusion. In the tonal system, there is a second type of scale, the minor scale, which has 3 different variations: natural, melodic, and harmonic. Here is the natural minor scale structure chart. At this point, we can already tell this is an elegant music system, built out of only a few intrinsic elements of sound. It's also a system built with logic, as if it was designed by Mr. Spock. Thanks for watching.